According to National Electrical Code Article 427.22, ground fault protection of equipment shall be provided for electric heat tracing and heating panels. Electric heat tracing and heating panels are defined in National Electrical Code Article 100 as an assembly of materials used to provide heat to a specific area or component by the passage of electric current through a resistive element. Self-regulating pipe heating cables are a type of electric heat tracing cable and would therefore be subject to the requirement for ground fault protection. A regular circuit breaker does not provide ground fault protection. A ground fault circuit interrupter breaker is required to provide ground fault protection. Ground fault protection is a critical safety measure designed to protect equipment from damage and to minimize the risk of electrical shock to personnel. It works by detecting imbalances in the electrical current flowing through a circuit. In a properly functioning circuit, the current flowing to the load should equal the current returning. However, if a ground fault occurs, such as when a live wire comes into contact with a grounded surface, a portion of the current will divert through the ground path. This creates an imbalance in the current, which is detected by the ground fault protection device. When a ground fault is detected, the protection device quickly trips the circuit, interrupting the flow of electricity and preventing further damage or injury. The National Electrical Code mandates ground fault protection in various applications where the risk of ground faults is higher, such as in industrial facilities, commercial buildings, and residential dwellings. Specifically, Article 427.22 addresses the requirement for ground fault protection of equipment for electric heat tracing and heating panels. Electric heat tracing systems are commonly used to prevent pipes from freezing, maintain process temperatures in industrial applications, and provide comfort heating in residential and commercial buildings. These systems typically consist of a resistive heating element that is wrapped around or embedded within the pipe or surface to be heated. When electric current flows through the heating element, it generates heat, which is then transferred to the surrounding material. Heating panels, on the other hand, are typically used for space heating or surface heating applications. They consist of a flat panel with a resistive heating element embedded within it. When electric current flows through the heating element, it generates heat, which is radiated from the surface of the panel. Self-regulating pipe heating cables are a type of electric heat tracing cable that have a unique property of automatically adjusting their heat output based on the temperature of the pipe they are heating. This self-regulating property is achieved through the use of a conductive polymer core that changes its resistance with temperature. As the temperature of the pipe increases, the resistance of the polymer core increases, which reduces the amount of current flowing through the cable and lowers the heat output. Conversely, as the temperature of the pipe decreases, the resistance of the polymer core decreases, which increases the amount of current flowing through the cable and raises the heat output. Because self-regulating pipe heating cables are a type of electric heat tracing cable, they are subject to the requirements of National Electrical Code Article 427.22, which mandates ground fault protection for electric heat tracing and heating panels. A regular circuit breaker is designed to protect against overloads and short circuits. Overloads occur when the current flowing through a circuit exceeds the rated capacity of the circuit breaker. This can happen when too many devices are plugged into a single circuit or when a device draws more current than it is designed to handle. Short circuits occur when there is a direct connection between two conductors of different polarity, such as a live wire and a neutral wire. This creates a very low resistance path for current to flow, which results in a large surge of current. Regular circuit breakers are designed to trip quickly in response to overloads and short circuits, protecting the wiring and equipment connected to the circuit from damage. However, regular circuit breakers are not designed to detect ground faults. Ground faults typically involve much smaller currents than overloads or short circuits, and they may not be sufficient to trip a regular circuit breaker. Furthermore, regular circuit breakers do not monitor the balance of current between the live and neutral conductors, which is necessary to detect ground faults. A ground fault circuit interrupter breaker, also known as a GFCI breaker, is specifically designed to detect ground faults. It works by monitoring the balance of current between the live and neutral conductors. If there is a difference in current of 6 mA or more, The GFCI breaker will trip the circuit, interrupting the flow of electricity and preventing further damage or injury. Ground fault circuit interrupter breakers are required in many locations where there is a high risk of ground faults, such as bathrooms, kitchens, and outdoor areas. They are also required for electric heat tracing and heating panels, as specified in National Electrical Code Article 427.22. When selecting a ground fault circuit interrupter breaker for use with self-regulating pipe heating cable, it is important to choose a breaker that is specifically designed for this application. Some ground fault circuit interrupter breakers are designed for general purpose use, while others are designed for specific applications such as electric heat tracing. The breaker should be sized appropriately for the load it will be protecting. The ampacity of the breaker should be equal to or greater than the ampacity of the self-regulating pipe heating cable. The breaker should be installed in accordance with the manufacturer's instructions and all applicable electrical codes. In addition to selecting and installing the correct ground fault circuit interrupter breaker, it is also important to properly maintain the self-regulating pipe heating cable system. The cable should be inspected regularly for damage or wear. Any damaged or worn cable should be replaced immediately. The cable should be properly supported and protected from physical damage. The cable should not be installed in areas where it could be exposed to excessive heat or moisture. The importance of ground fault protection cannot be overstated. Ground faults can cause serious electrical shocks and fires. Ground fault protection devices such as ground fault circuit interrupter breakers can help to prevent these hazards by quickly interrupting the flow of electricity when a ground fault is detected. National Electrical Code Article 427 provides detailed requirements for electric heat tracing and heating panels, including requirements for ground fault protection, overcurrent protection, and wiring methods. It is important to consult this article when designing and installing electric heat tracing systems to ensure that they are safe and compliant with applicable codes. Ground fault protection is a critical safety feature for electric heat tracing systems. Self-regulating pipe heating cables are a type of electric heat tracing cable and are therefore subject to the requirements of National Electrical Code Article 427.22, which mandates ground fault protection for electric heat tracing and heating panels. A regular circuit breaker does not provide ground fault protection. A ground fault circuit interrupter breaker is required to provide ground fault protection.